Lesson number 71 today is about trinomials with common factors and subscripted variables. So our first types of questions are going to look like this. They're going to ask us to factor. We have x to the third plus 6x squared plus 5x. Now these trinomials will have common factors. And we can see that in this trinomial, each one of the terms has at least x to the first power. So we're going to factor out an x to the first power. When we do that, we factor out the x. And then we're going to say x times x squared gets us to x to the third power. X times x squared gives us x to the third. Plus 6 times x, x times 6x gives us 6x squared. That's how we get this part. Then we're going to say plus x times 5 is going to give us x times 5. Now we've got this part. This is fantastic, but we still need to continue to factor, because we can break down this trinomial into two binomials. So what multiplies to 5 and adds to 6? In order to do that, we've got our x in front. We're going to set up two binomials. We know x times x is going to give us x squared. And then 5 plus 1 is 6, and 5 times 1 is 5. So we're going to get x plus 1 and x plus 5. And we've got our final answer. We factored this trinomial completely. And we did it by factoring our common factor first, and then factoring the leftover trinomial into two binomials. Let's look at another one. Our next problem asks us to factor again. First, we have to find out what we can factor out. So we have a 4, and an 80. Well, all of those numbers are divisible by 4, so we'll factor out a 4. We have a b, and a b. So we can factor out that b. We have an x to the third, an x squared, and an x to the first power. So let's factor out an x to the first power, since they all have that in common. Then we're going to say 4bx times x squared. That would be 4bx to the third if we were to multiply through distribution. Minus, well, we've got 4bx times, we're going to have to multiply it by x again in order to get to 4bx squared. Then we're going to say minus 4 times 20 is 80. B times 1 is b, and x times 1 is x. So we've got everything factored. Now we need to break down our trinomial. We're going to get 4bx, and I'm going to use a different color this time. And we're going to get two binomials from this trinomial by factoring. So we know we've got to multiply x times x to get to x squared. Then can you think of a pair of numbers that will multiply to negative 20 and add to negative, this must be a negative 1? Well, how about if we had negative 5 and positive 4? Negative 5 plus positive 4, that's negative 1. And negative 5 times positive 4, that's negative 20. So that would be our answer, x minus 5 times x plus 4. Other factors we could have had would have been 5 plus negative 4 would have been negative 20, but that wouldn't have added correctly. We could have also had 20 and 1. We could have had negative 20 times positive 1, but that wouldn't have added correctly. We could have also had negative 10 and positive 2. Even if we reverse those, just like here, it wouldn't add correctly. So this was our only possibility for our answer. We'll practice factoring more, but the more that you practice this, the better that you'll get. Let's look at our next example. Now this problem says solve by using the elimination method, and this problem looks different. This problem has subscripted variables. A subscript just means we've got like O2, like oxygen. We've got a big letter, or number, we could have, 2a, and this is the opposite of a power, because a power would be up high. This subscripted variable is down low. Now what this stands for is the number of nickels and the number of dimes. So n of n equals the number of nickels, and n of d is equal to the number of dimes. Now the alternative way that we could have done this problem would have been to say something like 5x plus 10y is equal to 125. And we could have said x plus y is equal to 16. But sometimes it makes sense to use subscripted variables if they make sense for the problem. Number of nickels, n of n. Number of dimes, n of d. Rather than using x and y, and those having no relationship to your actual problem. So if we want to solve this by using the elimination method, we do the same thing here as if we were working with x and y. We're going to have to take our second equation and we're going to multiply it. We're going to multiply that second equation by, and let's do by -5, because that will help us eliminate the number of nickels. So when we do that and we rewrite, we're going to get 5 times the number of nickels, that's our top equation, plus 10 times the number of dimes is equal to 125. Then when we rewrite our second equation, we're going to get -5 times the number of nickels, plus, well, we're going to have -5 number of dimes is going to be equal to -5 times 16. Well, -5 times 16, that must be -80. And here we can go ahead and eliminate to solve. We know when we eliminate, we always use addition. So if we eliminate, well, 5n, number of nickels, minus 5n of n, that's going to be 0. 10 plus -5, that's 5. That's our number of dimes. It's going to be equal to 125 plus -80. Well, that must be 45. We can solve here because we know 5 times 9 is 45, so the number of dimes must be 45 divided by 9, which is, or 45 divided by 5, which is 9. And we've got our answer. Now we've got to finish off the problem. I'm going to erase over here what we originally had. So in order to figure out the number of nickels we have, let's use our original equation. And we're going to erase here to see that the original equation was very simple. It was the number of nickels plus the number of dimes equals 16. So you might be able to figure out what the number of nickels is by knowing that 9 plus that number gives us 16. We could write it out, the number of nickels plus the number of dimes, that's 9. It's going to equal 16. So how many nickels do we have? Well, 16 minus 9 gives us 7. So the number of nickels, that must be equal to 7. And we've got our final answer. Our lesson practice will be on page 290. Make sure you've got your notes complete, and I'll see you during our next class.